All right. That's not what I want to do. Okay, hopefully now you can see the slide and not the presenter view. Yeah, thank you everyone so much for coming. I know we have people from all over the world. I heard, I think, West Coast, Midwest, and East Coast in the United States. I heard North Macedonia, Pakistan, India. So really a global meeting today here. So thank you for those who are up late, up early. I definitely appreciate that. So we are going to be going into an Apex testing deep dive today. My name is Adam Olshansky, and happy to be presenting at the Mountain House developer group. So a little more about me, as Manoj mentioned, I'm a Salesforce MVP. I lost track of, I think, 4 or 5 times now. The years have kind of blended together the last couple of years, but I'm now my title is Salesforce Architect on the Google Play team. I have 15 certifications and over 700 Trailhead badges, but I'm really passionate about helping people learn to develop on the Salesforce platform. Feel free to follow me on Twitter, Adam17AMO. Follow me on LinkedIn. I also have a blog, adam2architect.com. And if you are still not yet on the Lightning experience or looking to catch up on your kind of Salesforce security on the declarative side of the platform, I have a couple of Pluralsight courses, bit.ly/lightning migration and bit.ly/Salesforce data sharing. All right, today we're going to be taking a deep dive into Apex test classes though. And so I'm going to skip over some of the parts where we talk about like how to create test data, but I will be sharing a GitHub link at the end of the presentation with all the code we go over, and that'll include some code for a test factory and some other ways to upload test data, creating it on the fly, creating it via static resource and things like that. But today I'm going to specifically focus on a couple categories. The first one's going to be the kind of system test class that's part of the Apex language, and also focus on using that to test asynchronous code in Apex, so code that doesn't run immediately, but maybe runs on a schedule or runs when resources are available. I'm also going to be going into how to test external callouts. So for those unaware, if you were calling out to an external system, you cannot do that in the context of an Apex test class. And lastly, we are going to be going over how to debug failed tests and also play around with the Apex replay debugger. And so we'll have, I think, 3 demos, one for each of these topics as well. And then at the end, we'll do kind of a recap to wrap everything up. And so one thing when we are always talking about tests, it's always the question of, okay, why are we testing? And this is one of my favorite GIFs here. And I think it really captures why we want to test things. Because at the end of the day, we can write great code. We think we know how users are going to use it. And users tend to find interesting ways to use the things that we write. Maybe they have inputs we don't expect. Maybe they're going through a different workflow other than the one that we set up for them. There may or may not be training available. They may or may not be following the training, right? And so tests are a way to basically do our best guess to try to figure out every possible way users can use our application, our code that we write, and make sure that we're accounting for it, handling errors gracefully, and not getting into a situation where the user is either getting stuck, getting an ugly error message, and things like that. All right, so the first topic I want to go over is kind of the system level test class that's part of the Apex language, as well as testing asynchronous code. All right, and the first way I'm going to start talking about that is by talking about how to avoid limits in tests. So if you think about it, right, when I'm running my normal application, right, or maybe we'll take one step back. For those unaware, Salesforce runs on a multi-tenant architecture, which means many different customers are using the same backend resources you are, the same servers, the same storage, the same databases, things like that. And Salesforce segments it off by customer. But as you know, you're probably on some sort of pod, right? NA, 100, some other prefixes as well, but you're using the same resources as other people. And for that reason, Salesforce has in place governor limits for basically how many resources can you use as a single customer. So these are going to be things like, I can only use 100 SQL queries per transaction. I can only use 150 DML statements per transaction, right? These are limits that Salesforce puts in place to basically make sure you're not using more resources than you should be. And normally when a user is running, the program, none of the limits have basically been utilized yet, right? When a user starts clicking a button, going to a page, you have the full set of 100 SQL queries, 150 DML statements, and things like that. But when you're testing, you have to basically prepare the testing environment. So you might need to create some data to test with. And by creating an account, for example, you're probably going to fire off some account triggers, or ideally one account trigger that's going to fire off various other processes that's going to use up some of your limitations. And so how do we get around that so that, right, we don't want to be in a situation where creating all of our test data takes up half of our limits, and now we don't have our full resources available to us in our test, and we can't really properly simulate a user's experience. And so for that, we're going to be able to utilize the test class in Apex, and specifically two methods called test.startTest and test.stopTest. And so what these are going to do, you can put them in your test, and they're basically going to reset the limits. So I can create all my test data, run 50 SQL queries to do that, call test.startTest, and now that's going to be reset back to 0. And test.stopTest is going to be the end of that kind of reset limits block, and then I can keep running my asserts and things like that. But those are a couple of the methods we can use in the test class that's part of Apex. I see there's a question in the chat. Oh, never mind. Link to join Slack. Okay. All right. Yeah, feel free to put questions in the chat. We'll also have a Q&A at the end if you want to hold your questions to the end too. All right. Another way to avoid limits in tests is going to be by bulkifying record creation, right? So these are things like if I need to create 5 different accounts for my test, I can create an account, insert the account, create a second account, insert the second account. And each time I insert accounts, I'm going to fire off all of my account triggers and classes that run. And so to avoid this, right, pretty easy way to get around that, just put all the accounts in a single list and run a single insert statement. So whenever possible, try to bulkify your test data creation. Right, creating records without DML. So there are a couple ways to do this and a couple reasons to do this. There are some tests, for example, unit tests, where we're just testing a single method, right? Maybe some sort of like code validation. We have an account and we just have to check some fields on it, right? Or we have an account, we want to check some contact records, how many contact records are under it. When we're testing this though, we don't necessarily need the account in the system. We just need an account to pass into the method. And so we can potentially save ourselves having to use any of our limits and some processing time of having to run all the triggers by just creating an account in memory and then passing it into our test method or our actual method. And we can do things like utilizing test factories, maybe adding a separate parameter for should we run DML or not, true or false. And in some cases, we can ask our test factory to create records for us and insert them, or we can ask it to create records and just pass them back, and then either manually change some fields before running DML, or just skip the DML altogether. But it's another way to avoid limits in tests and also increase your processing time a little bit. All right, and then, I don't know what happened there. All right, 1 second. Okay. All right, and then the last one is to split up tests by use case. So one thing I've seen is people want to just write one test and try to do everything. And the problem with that is, right, as you can imagine, if every time I run my process, I'm using 30 SQL queries. If a user is running a process, it's not a big issue. But if I'm testing 4 different things in the same test, I'm running those 30 SQL queries 4 times now. And so now I'm going to run through my limits, and I'm not going to be able to get a proper test in place. And so splitting up tests by use case, again, is going to be another way to reset your limits and avoid running into that in the context of your tests. Because one of the most annoying things is when your code's working properly, but you have some issue in your test classes and your tests are failing as a result. Hi, Adam. I'm sure you're going to cover it. I want to bring up the people awareness use it very often. We can use test setup and query for the records and actual test methods. Great point, Nagesh. So for those unaware, and I think I have that in the longer form version of the presentation, but there is a special method in test classes called test setup, which will basically allow you to avoid having to duplicate every time you create records for tests. So instead of creating the same 5 account records in each test, I could put them in a method annotated with @test_setup, and that's going to run before each test runs. So I can reduce the duplication in my code and I can make sure I'm consistently creating records the same way for every test. And then as Nagesh mentioned, when you are using test setup, you do need to requery for the records because the individual tests don't have a concept of the variables you use to create the data in test setup. So you will have to use a little bit of some of your limits, but again, you can get around it affecting your test using test.start test and test.stop test. All right, and then another way we can get around limits and tests, not maybe the best way to do it by utilizing the test.isRunning test. So there are some cases where for our actual processing, right, maybe we'll want to take them to a wizard that's going to run a bunch of queries and do a bunch of things. But if we're running a test, right, there's not really any concept of showing a user a wizard. So we can maybe skip some of that processing. So we can put, again, utilizing this test class, the method isRunningTest in our code and control the behavior, what our code is doing if we're in the context of a test class versus in the context of a user running the code. All right, and now let's talk a little bit about asynchronous testing. And so when I talk about asynchronous testing, there are a couple different kind of areas that covers. So this is going to be future methods. If we annotate a method with @future, so it's going to run when resources are available. And again, for @future, you will also get to double some of your limits. I think this will allow you to run 200 software queries for a transaction, for example. Another asynchronous method is going to be batchable. So you can annotate a class with the batchable interface and implement the start, execute, and finish methods and run code in bulk with different batches. There's also queuable, which is kind of similar. You can kind of queue things up and then run them as the previous one's complete. You can chain jobs together, another way to run code asynchronously. And then schedulable also. And one thing to note about schedulable classes when you're testing them, if you are running a schedulable class in your test, it will be scheduled, but the job won't actually run. What I mean by that is if I schedule a batch class, for example, and I fire off my schedulable class to run in my test, I'll be able to query when it's scheduled for, but when I tell the scheduled job to run, it won't actually run the batch class. I have to explicitly run the batch class again within my test method for it to work properly. In one test method, I think you can use it only, real quick, is it possible to use test.start test, test.stop test in the same class more than once? And thank you, Nagesh, for the answer. No, you can only use them once per test method. So you can use it in the same class, but only once per test method. And so if you are using it to reset your limits, be cognizant of where you put them for sure. All right, so once again, test.stop test is going to come in handy for our asynchronous processing. So again, keeping in mind, you can only use it once per test method. Normally, this code will run asynchronously, but if we are in a test, it's going to fire synchronously. So let's say I have a scheduled job that's supposed to run at 1 in the morning. Obviously, it'd be a pain if I have to wait to 1 in the morning to actually run my test. And so I can have it scheduled for 1 in the morning, call test.stop test, and it'll fire immediately. I'll then be able to query when it's supposed to be scheduled for, but my asynchronous code will run immediately on test.stop test. And after test.stop test, then I can go verify properly ran, verify the results using various system.asserts.
Hi, Adam. Can I ask one quick question here?
Sure. I cannot see who's talking, but yes.
You mentioned that with the schedule level, right, it can only schedule, but it won't run the job, right? What if I want to verify whether that schedulable class, executed the subsequent batch job or not, whether it's a batch job or any Apex class it runs, right?
Yeah, so you will be able to query that it is supposed to be scheduled at a certain time. I think by querying I want to say the Apex job object, you can query what has it executed, has it run, things like that. But it will not actually run the batch job itself. So if I schedule a batch job, I can verify the scheduled job is scheduled and it's run. But if I want the batch job that it's supposed to schedule to actually run, I still have to explicitly call the batch job in my test class.
Okay, got it. Thank you.
Yep. All right. And then a couple other things you can do with the kind of test class that's part of the Apex language. We mentioned test.isRunningTest. There's also test.setCreatedDate. So this is a relatively new method. I guess it's not relatively new anymore, maybe it's a couple years old now. But you can specify the created date. So normally when you create a record, there's nothing you can do to change the created date because it's a system field and it gets set whenever you create it. But if I want to test some data that is old, for example, I can use test.setCreatedDate only when you are creating a record and only in the context of a test class, and change what the created data is supposed to be. Another usage for it is test.setCurrentPage. So if I'm doing some tests on a Visualforce page and I want to pull in some parameters from the Visualforce page, I can specify what the page should be with setCurrentPage, and then extract some parameters and do some other things in relation to that Visualforce page as well. All right. So I'm going to go through a scenario, and then we're going to see a demo and of some asynchronous code and some of the kind of test class methods. And so in our example here, we are going to be using a class called case reassignment batch. And so I've created a queue in my org called temp queue. And we're assuming that records get assigned to the temp queue periodically. And my case reassignment batch, what I can do is I can pass in a specific user to my constructor, and it's going to query all cases owned by the temp queue, and it's going to assign them to a specific user. All right, so let's go take a look at that in action here. All right, so let me bring up my VS Code here. All right, and can everyone see that, or do I need to make it a little bit bigger?
That's good.
Okay.
Yeah, it looks good.
Okay, perfect. So I'm going to move this out of the way. Okay, so we have our case reassignment batch class. It implements database.batchable. I have a start method here in line 9, and in line 11, I am getting all the cases where the owner is the temp queue. And we see in line 5, my constructor, I'm passing in a user ID. And all I'm doing in the execute method is taking all the cases that are owned by the temp queue, and in line 18, changing the owner to be whatever user ID I passed in. And then at the end, we're printing out how many cases were reassigned. And so if I go to my test class, tests class, I have a couple of methods here. I'm going to jump ahead to this batch reassignment test. And I'm going to start running it. And in the background, we're going to see, right, we're going to query for the temp queue in line 26. I have a test factory I'm calling in line 28 to create some cases. We're going to create 10 cases in this case. And I'm going to set the owner to all my cases to be the temp queue. If I pull up my test factory real quick, I'll see in create cases, I have this parameter, whether or not should I perform the DML. Again, a way to get around our limits if we don't actually need to insert any of these records. So in this case, I passed in false, I believe. Oh no, I passed in true, sorry. Okay, so I am inserting the cases, and then I'm changing the owner to be the temp queue, and then I'm updating the cases. And then I'm doing a quick check just before we actually run our batch. I'm querying all cases owned by the temp queue, and I'm confirming that all the cases that were created, which should be 10, is the same as the number of cases owned by the temp queue, which should also be 10. All right, and then in line, we see here I have test.start test. I have my code to specify my batch, case reassignment batch. I'm passing in the current user. I'm executing the batch in line 41. And because it's asynchronous, when I call test.stop test in line 42, it's actually going to run. And so when it does, now I can query to see how many records are owned by the temp queue in line 45 and line 46. I'm going to confirm that nothing is now owned by the temp queue because my batch class is run. And line 47, I'm going to see how many cases are owned by the current user. In line 48, I should see that all cases are now owned by the current user. And I see here that my test class did pass here. Right, so we see test.stop test called my asynchronous code to run. If I go take a look at this test up here, test extended governor limits. Once again here, I'm going to run this test in the background. I'm going to create 100 accounts. And I'm going to do something you should never do in code, which is put a SQL query in a for loop in line 8. And for each account in my accounts I just created, which is 100, I'm going to run a SQL query. And so I'm running 100 SQL queries. And so in line 11, I'm confirming I've actually run 100 SOQL queries. And in line 12, I'm confirming that the limit of queries I can run is also 100. So I'm confirming I've maxed out my queries. And then I call test.startTest. Line 15, I confirm that I do indeed have a new set of limits. I run 10 more SOQL queries. So I've run 110 SOQL queries total now. And line 20, I confirm that because I'm in my test.startTest, test.stopTest block, I've only actually run 10 queries. So as we can see in this test, it looks like passed as well. And so I can confirm that I've only actually run 10 queries in this block because I've been able to reset my limits. All right, and then the last one here is for testing old data. So I'm a big fan of Harry Potter, and so I'm going to create a new record called Harry Potter First Movie, and I'm going to insert it. And I'm going to specify a new date time in line 55. That's going to be the date that the movie was first released, at least in the United States, which was November 14th, 2001. And I'm going to, again, use a method from the test system class, test.setCreatedDate, and specify that the created date of the account I just inserted should be November 14th, 2001. And then I'm going to query this record, get the created date, and confirm that the created date of the record is, in fact, the date that I specified using test.setCreatedDate. And once again, we see that the test is passing. So great, we're able to both test asynchronous code and take advantage of some of the methods in the test class, part of the Apex system class. One thing to note about this class, we had somebody on one of the teams I was on do this suspiciously on his last day before he was taking a new job. He created a class called test. And when you create your own class called test, anytime you call things like test.setCreatedDate or test.startTest, it looks at your class called test instead of the Apex class called test. And any test that has any of these in it will start failing. So be very careful about doing that. Like I said, the timing that this individual did it was a little suspect, being his last day. But you know, that is a mystery for another time. But do be careful if you're creating a test class, or creating a random class and just try to think of a quick name. Use something other than the name test. All right. Let us go back to our presentation then. All right, so now let's talk a little bit about testing callouts. So as I mentioned, when you are testing code in Apex, you cannot make callouts to external systems. And because of that, we still kind of want a way to make sure our code is working. We're able to handle successful responses. We're able to handle bad responses, right? Going back to the user who didn't know how to drink the water, somebody does something weird with an external system, we have to be able to handle that. And we also want to make sure that when a response does come back, it's doing everything we expect it to. And for that reason, we can create what are called mock responses in Apex. So we can basically set up dummy data that we use as our response so we don't have to make an external system call out. And the best way I found to figure out what this should look like is by running an external call out in a sandbox and using system.debug to print it out, and then just basically doing a copy and paste and making that your mock response so it simulates a realistic response from an external system. We take advantage of another method in the Apex level test class, test.setMock, to specify which class that holds all our responses we should be looking at for our test. And then we can proceed with actually mocking it. And so when we are generating mock data, again, we want to make sure we're modeling it after actual API responses. And we also want to make sure we're capturing different response codes. So we want to make sure when everything works perfectly, obviously it's working. That's probably the most important use case. That's going to be our 200 OK response code. So when we get good data back from our external system, did our code work or not? But we also probably want to consider other codes that could happen, maybe when we're testing on our own, or other things that could happen from the external system. So this could be a 403 forbidden error if we have invalid credentials, maybe. Could be a 500 internal server error if the external system is down, right? We want to make sure that we're able to gracefully handle these errors, and it's not just going to blow up in the user's face, because users generally don't understand what 500 internal server error means. And so we want to make sure we're handling it appropriately on our side. And there are several different ways to basically go about handling all these different responses. We're going to see one where we use kind of the constructor method, but we're also another option. Another option that we can do is to create a map to hold multiple responses, and this can be used either to map different response codes, or even if we need to test different APIs in a single mock class, we can have a map, say, for API number 1, we have this response, for API number 2, we have that response. And so we can use a map for that as well. All right, so for our scenario here, we are going to have a custom object in our org called purchase order. And a purchase order is basically going to be holding data that exists in an external system. We just want to bring that data into Salesforce. And we're going to do that using an external ID. So this is probably some payment that was made. The source of truth is an external system, but we want to be able to see the data in Salesforce. So we're going to make an API call out based on an external ID in Salesforce, which will be the ID in the external system. And it'll bring all the data back and populate Salesforce when we get the response back from the API call. And like I mentioned, we're probably going to want to handle different responses from our API, right? We're going to want to handle our everything's working well path, right? Our 200 OK response code. We want to handle our 403. There's some maybe security credential error, and we want to handle the 500 internal server error. Something went completely wrong on the external side. And so the code on our side isn't doing a ton. We're setting the endpoint in our code. Normally, we'd probably do it using a named credential or using custom metadata. But here we just set it in the code. And so it's just going to some random website. And at the end of the URL, we see the external ID being appended to it. And then we see try catch block. We're making an HTTP call out. And we're just checking to see, is our status code 200? Did everything work properly? And if so, we're just constructing a wrapper object from our response. And we're going to call a method called update purchase order. And it's going to use a purchase order ID from Salesforce that was populated or passed into this method, as well as the results we got back from our API. And if things did not go well, we did not get our OK response code, we're just going to print out error syncing PO with the status message. And we can also catch any error that happens as well. All right, so we call it making our HTTP call out. Let's take a look at the update purchase order method. We're passing in the Salesforce purchase order ID and the API wrapper object. And here we see all we're doing is we're getting the fields from our purchase order object in Salesforce using the ID, and we're just populating them one by one. So the amount field in Salesforce should come from the amount field from the API. Amount still owed in Salesforce should come from amount remaining in the API. Description should come from description. Name should come from name. And then we're going to run some DML to update our purchase order. All right, so with all that in mind, let's go take a look at our mock and our test in action. So I am going to now pull up. Oh, I forgot to look at this before also. Our test.is running test in action. So we can say if test.is not running test, this is maybe a less clean way to run different code, right? We can call it a method called make external callout. If we're running a test, we can call a method called make test callout. The mocking framework is basically going to be a better way to do this, but here we see the test.is running test in action. And so I'm going to take a look at our purchase order sync test. And we're going to start off here creating a just dummy purchase order with nothing in it, right? We just populate the name and we populate the external ID. And then again, we're going to put it in our test.stop test. We don't need to, just makes it a little bit cleaner to do so. And again, we're calling this test.setMock method in line 11. And we're going to pass in an instance of our mock class, purchase order mock, and you see we're passing in a 200 response code. And so if I go take a look at our purchase order mock class, we're going to see that in line 2, it implements HTTP callout mock. And we're going to use the constructor approach to basically specify a different response for each status code. There's also the mapping option. Again, you can map for different endpoints. You can map for different response codes. And I have a link to the blog on the developer website if you want to take a look at the code and check that out as well. But for now, line 6, we just see a constructor to basically create an instance of purchase order mock with whatever status code we want to run it for. And the HTTP callout mock interface has a single method you have to implement called respond, and it takes in an HTTP request. So when our code is making our external callout, because we called test.setMock, instead of trying to make the external callout and getting an error, we're not allowed to make external callouts in a test. We go into this purchase order mock class instead, and we're going to hit the respond method. And the respond method is going to basically pretend to be the API response. So it's going to create an HTTP response object. We're going to set a header. We're going to set the status code to be whatever we passed into our constructor. And then we see in lines 16 to 25, based on whatever status code we passed in, we're going to set a different status and we're going to set a different body. So for the 200 status, we're going to specify the OK the OK status. For the 403 status code, we're going to specify the status authentication failure. And for the 500 status, we're going to specify internal server error. And then we're just going to return our response in line 29. And if you take a look at our different responses, again, I just took this from a basically mock API callout where we just have a JSON that we can return as our body. And here we see we're specifying the external purchase order ID, ABC123. We're making a big Dreamforce Astro purchase for 150,000. We have 10,000 remaining. These are going to be Astro plushies for Dreamforce. And we see we have a 200 OK status being returned here. If I passed in different codes, I might want to return the authentication failed response. So again, I'd return no results because there was a failure. I'd return back the status and the status code. And once again, if there was some error, I would return no results. And again, I would return a 500 status code and an internal server error status. So with that in mind, if I go back to my purchase order sync test, right, I'm going to kick off this test, and we see again ABC123, which matches the mock data we had. I'm going to set the mock in line 11. I'm going to call my code, purchase order sync.syncpo, the code we just looked at in the PowerPoint. And I'm going to get a status code back. And because we passed in 200 to our constructor in line 11, that means we're going to return the OK response in our mock, which is going to end up returning 200 in our purchase order sync class. And then after test.stopTest, we can go and assert everything. Our code worked as we expected it to. So our status code should be 200. And then if we requery our purchase order, because we saw that update PO method where everything gets updated from the API, even though I inserted a dummy purchase order with no data populated in line 8, we can now see that all the data has been successfully populated. As we see, this test looks like passed as well. Yep, so we got another pass here. And so we see our API mock in action here for the 200 response code. If I wanted to test some of these other responses, I could insert the same dummy purchase order. I could specify a 403 response in line 31. And now when I requery my purchase order in line 36, we reset the name, but now everything else should be null because our results returned back 0 from our mock API. And that means we never actually got to the point where we were populating the data in our code. And so in this case, boy, our test finishes soon. We should also see this test passing, asserting that our purchase order has not actually been updated. And while that runs, we'll take a look at our server failed, which does the same as our basically forbidden status. We're just passing in 500 in line 51. And once again, when we requery the purchase order, we see that none of our fields actually got updated because it was not a positive response. Let me try running it again. Okay, so I don't know what was going on with the previous one, but we see this test passed as well. And the 403 one works the same way. One other way we can, when we use test.setMock, one way is the way I just showed, where we use the HTTP mock interface, HTTP callout mock interface. There is one other method, and that is using a static resource once again. So I could have a static resource called purchase order response.json, and I just put a JSON in here, again, the same API results we had before. It's ABC123, the Dreamforce Astro purchase for 150,000. I'm going to get some Astro plushies for Dreamforce. return a status of OK, a status code of 200. And once again, I'm going to insert my dummy PO. I'm now going to use a different class called static resource callout mock and specify that the static resource should be this purchase order response.json. I specify my status code here. I again call test.setMock, but instead I use this mock I just created, the static resource callout mock. And once again, it's going to work the same as our first test because we are returning a 200 response. Once again, our purchase order is successfully updated from our mock API call. And we see that this test passed as well. All right. So as I mentioned, different ways to mock. We can use the constructor that we saw in the code. We can use the static resource we saw in our test. And we can also use a map. And this is very helpful for when you have different endpoints you want to use the same class to test. You can map different responses to different endpoints and use the same mock class to do all that.
So Adam, just a question. So for the SOAP-based URLs or the APIs, the mock will be the similar, just a different definitions, right?
That is my understanding, yes. I have not actually worked too much with mock SOAP callout. Yeah, this is, I guess, primarily for REST. I would assume SOAP works the same way.
Yeah, it would be same. I mean, probably the same, only the way here, just a request response, that it has to be SOAP with the header and the envelope and all the things.
Yeah.
So another question on this. So we basically bypass all security and we just test the actual response and request body, right? Nothing actual included with the API.
Yeah, so here there's no actual credential passing. So we, in theory, would be passing credentials in our code, but we're just assuming they're either accepted or rejected and returning a response accordingly. So like the 403 test, I assume the credentials were rejected just to make sure our code could handle it properly. Okay. All right, so last major topic I wanted to cover was on debugging tests. And so as we saw in the code, one of the things I like to do, and again, mentioning the test setup, basically after all your data is created, whether you're using test setup, whether you're creating the tests, the test data ad hoc, whether you're using a static resource, do some sort of sanity data check. And so this means like, right, what we saw when I created, when I ran 100 SQL queries, I'm confirming before I actually run any code, I used 100 SQL queries. Before I ran my batch class, I assigned 10 cases to the temp queue, and then I confirmed that 10 cases were in fact assigned to the temp queue. And this allows me to easily compare before and after values. The other thing, right, that it allows, so the other thing that before and after values allow you to do as well is to use a relative value rather than hard coding. So in this case, I did hard code some things like create 10 cases, things like that. The problem that we run into with that is, let's say I have at another process somewhere else that's creating a case behind the scenes whenever I create an account, for example. If I create 10 cases in an account, and then I assert that there should be 10 cases, now maybe there's going to be 11 cases. By using kind of relative values, I don't necessarily care how many cases other things are inserting. I just have a set value, and then after my code runs, maybe I want to confirm that whatever value it was before, I now have 3 additional cases. So I don't have to confirm the numbers are 10 and 13. I can just confirm it's at some value, and now it's at some value plus 3. And so that allows me to more easily figure out, is there an issue in my test, or is there an issue with the code somewhere, right? Because it's also very annoying when your code, right, it's kind of a false positive, right? Your test passes, but it doesn't actually work. But it happened to pass because another process was creating the missing case. Try catches are also good. So when you're running into different exceptions, catching whatever error it was, printing it out, putting some asserts in your catch block, putting Booleans in your catch blocks to confirm that your catch blocks actually ran, right? One thing I see frequently is people will have try catches, assume, and then all their asserts are in their catch block. and the test passes, so they assume it works, but the exception was never actually triggered. So it just successfully ran everything in try, and then the test passed. And so it might make sense to either put an assert, maybe system.assert false after where the catch is supposed to be triggered in the try block, or to put a Boolean that changes to true if it hits the catch block, and then after either in the finally or after the try catch, to assert that the Boolean did in fact change to true. And whenever in doubt, especially at the beginning, use system.debug wherever you need it. I use it a lot of times to check where am I at in the context of how many limits have I used, how many records have been created, what is the data, and then I can figure out, okay, where actually is something going wrong. If that doesn't work and you want a more granular approach, though, you can also use the Apex Replay Debugger. So the Apex Replay Debugger basically lets you walk through code step by step, and it replays your test run, basically. So whenever you run your test, it'll generate a log, and then you can walk through that debug log and figure out where exactly is your code going wrong. And you can set as many breakpoints as you want for it to stop at, and you can also set up to 5 checkpoints, which are basically breakpoints that just give you additional data. And from there, you can walk through each breakpoint and figure out where exactly is my error occurring. And so I'm going to go walk through debug a test in real time using the Apex Replay Debugger. And so I'm going to go pull up VS Code again. And so I have a class called Test Factory Tests. And on my account trigger, I have a field on account called match billing address. And so this is like the checkbox you see on pages when you're filling out the billing address and the shipping address, and you check the box that says shipping address should be same as billing address. And it's supposed to update all of the shipping fields with all of the billing fields on the account. And so if I take a look at my test factory test here and I run this, this is just checking match billing address on some account that I've inserted. I'm setting it to true. I'm updating the account. I am going to get some contacts. I'm updating some accounts. And when I click update accounts, it should basically match the shipping address to the billing address. And then I'm confirming that all of the billing streets and the shipping streets match. And I see that this test has failed. Here we go. Test ran, fail rate 100%. And I see there is an error in line 37. The billing state is not matching the shipping state. So again, I used Harry Potter's home address, number 4 Privet Drive in Little Whinging, Surrey. And I see the billing state is supposed to be the state of Surrey, but it is actually the city of Little Whinging. And so I want to go debug that and figure out what's happening. And so to do that, VS Code, if you install the Salesforce extension pack, comes with the Apex Replay Debugger. And all I have to do to get it to work, this may be done for you already, but if it's not, you can create a folder up here called .vscode. And under .vscode, you can create a file called launch.json. And within the launch.json, you'll see this option here to add configuration. And when you click add configuration, it'll allow you to add some configuration for the Apex Replay Debugger. And so when you add configuration for the Apex Replay Debugger, it'll automatically put all of this code in there that basically allows the Apex Replay Debugger to run. All right, so once we have that in place, we can go to our account trigger and we can start setting some breakpoints of where we want our code to stop. So I know something's going on with the city and something's going on with the state. So I'm going to put a few checkpoints in here. So I'm going to go to line 7, where it's updating the city. I'm going to go to SFDX toggle checkpoint, and I'll see a little red checkpoint here shows up on the left side. I'm going to put it on line 10 as well, toggle checkpoint. And I know something's going on with the state, so after the state code runs, I want another checkpoint to see what happened. So I'm going to put 3 checkpoints in here. And then I'm going to run another VS Code command called update checkpoints in the org. This just basically is VS Code going to see what checkpoints you've added and registering them so it knows where to stop. Once I've done that, I can run another command in VS Code, turn on Apex debug log for replay debugger. So once we do this, we're going to start capturing logs in VS Code to be able to run the replay debugger on them. Okay, so I've turned on the Apex replay debugger. I can now go run my test again. And now we're capturing logs on it. And so once again, since we haven't actually changed anything in the code, we're going to see this test failed again. And once we see this test failed, we're going to go generate a debug log here in this tools folder under .sfdx. And under debug and logs, we're going to generate a log. So it captured the log. We just have to put it here now. If you captured a debug log in your org, you can also download it and upload it here as well. But instead, I'm going to run a command in here, get Apex debug logs, and it should bring up what logs have been captured. So I was testing this earlier. It's 5 o'clock here, so I'm going to go pick this log. And now I see this log has been generated. And I see basically everything that ran in my test is now showing up here. Okay, so I'm going to go now use the Apex replay debugger to walk through this. So I'm going to right click and click on Launch Apex Replay Debugger with Current File. And when I do that, it kicks off the Apex Replay Debugger. And I see, okay, now we're at the point that we're here in line, this first line here where we're starting our log. So I'm going to go continue running through this log until I get to my first checkpoint in my account trigger. And I do that. Now I'm in my account trigger. I'm on line 7. I see my context of this. I see it's my account trigger. I also see for each account I'm inserting, each account A, I have this value of A. And I can see all the fields in my account A. And so here I'll see, right, the billing country, the billing street, match billing address, match billing postal code, match billing state, billing state, all that's populated. So line 8, I'm going to change the shipping city. So I'm going to jump to my next checkpoint in line 10. I see that my shipping city has been changed to Little Whinging, which should match my billing city of Little Whinging. And now this is where our problematic code comes into place in line 11. Something's going on with our shipping state being invalid. And so I go look at my billing state. The billing state is Surrey, as we expect the shipping state to be at the end. If I go continue to my next checkpoint, I see the billing state is still Surrey. The shipping state is now Little Whinging, which matches my shipping city of Little Whinging. So that's interesting. So it's not populating the shipping state correctly. I can now go take a look at what code previously ran, and I see the shipping state in line 11 has been actually set to my billing city instead of my billing state. So that tells me something's probably wrong there. All right, so now I found where my issue was. I can go finish out of this, finish the execution here. I can change this to be billing state. I can save this. I can deploy this to the org. I can do that real quick. Terminal. Let's see here. Find my command to push this to the org. Is it here? I wrote this recently. Here we go. Deploy Apex trigger, account trigger. Okay. There's an error. Why is there an error? Let's deploy Apex trigger, account trigger, not trigger. Okay, let's try this then. If I go into the org directly, and let me make the change here instead. So if I go into developer console and I pull up my Apex account trigger, and here I change billing city to be billing state, and I save that. If I then go run my test again, with the help of the Apex replay debugger, I should now see that my test has successfully passed. So that's a way you can use the Apex replay debugger to help you debug your failed tests. All right, so just to wrap things up here real quick, we talked about a little bit about why we test, right, to make sure we're accounting for different ways users can use the system that we might not necessarily anticipate. We talked about how we can use the test class as part of the Apex language to do things like getting around limits and also firing our asynchronous code. We talked about how to mock tests for external callouts, and we talked about how to debug tests using the replay debugger. And so hopefully this has given you a bigger picture into some of the other things you can do with testing Apex. Beyond testing Apex, also some things might be worth playing around with if you're doing some Lightning component development. There are some commands in the Salesforce CLI for creating and running tests on Lightning components as well. They're not required, and I'm not aware of any plans to make them required anytime soon. But good to know they're there, another technology to play around with as well. And with that, thank you so much for everyone joining all across the globe. Feel free to follow me on Twitter, my blog. If you're interested in the code as well, you can check it out from my GitHub, github.com, adam17amo/apex testing. And I believe the recording will be made available as well. Thank you again for having me.
Thanks, Adam. Thank you very much. I never used the Apex relay test debugger, so that's a really good demo. Appreciate. So if anyone has some questions, we can open the floor for questions, and then after question answer, I'll stop the recording. Yeah, please feel free to ask any question related to this session or any around testing in Apex.
Hi, Adam. I opened the links that you sent us, right, regarding the job openings. It is showing like the 700 plus jobs, but not the one you were referring to.
Okay, let's see. That's interesting. Okay, it should be, so it says, yeah, 7,000 jobs matched, but it should be pulling up this one here. If that doesn't work, the way I got to this, just go to careers.google.com. And if you search for Salesforce, sorted by relevance here, but maybe search for Salesforce Technical Architect. That should narrow it down. But there are a bunch of different jobs across Google also. Some in India, some, I don't know if this is actually Salesforce or not. But if you search for Salesforce Technical Architect, it should pull up this job here.
Okay, all right.
Yeah. Any other questions on testing, Salesforce at Google, Salesforce in general?
So I don't have any questions on testing, but I do have some, I need some suggestion around the HTTP request callouts, right? So, so do you guys use some framework or some built out any framework to make all API calls through that sort of Apex framework? Because so one of my developments, so I have tons of API calls, external system API calls, and back and forth, and pretty much follow the same pattern. Gets a what token and then does start. So I need some suggestion around any kind of a pattern or some framework which can be followed to reuse. So most of these things, we can create those, but if you have some guidance on that suggestion, that would be great.
Yeah, that's a little tricky because every company kind of handles external callouts differently to some extent. So like for Google, most of our external callouts are to other internal Google systems. So we have to have like specific service accounts and register those, and we have to go through an intermediary to be able to get to any of the other internal systems first. So we usually store various things in like custom metadata, and then depending on whether it's production or sandbox, we'll have different custom metadata entries that we use for like the endpoint, the account name, all the credentials and things like that. I don't know that there's like a single framework necessarily I could recommend. But
yeah, mainly like any REST call. So basically it follows same pattern like any external API. Let's say I'm connecting any product and it has a OAuth and that's a access token, and then it does use like I can set up my Postman like that, and it does reuse. That's everything. Name credentials is the one way, but there are a bunch of things you have to do through code and all, and then there are lots of security ways you have to handle those. So in that perspective, some high level, yeah, that's what I'm asking.
Yeah. Yeah, for the most part, whenever you can like reuse methods, definitely recommend doing that. So all your APIs are following the same kind of process of whether it's OAuth or whatnot. And so whether you are using custom metadata or named credentials, having some sort of reusable way is definitely the way I'd recommend to go. In terms of the specifics on how to implement it, I think it kind of depends on how your systems are set up, what type of authentication, things like that.
Yeah, I saw your trigger frameworks, variety ways how you build triggers. That's pretty awesome. So something in that line.
Yeah. Yeah.
Calling out the external APIs. Okay. Good.
And a quick question, follow-up question on the API calls.
Yeah.
You mentioned that you are using custom metadata types or custom settings, right? Why haven't you leveraged name credentials?
Yeah, so I think there are probably use cases across Google for named credentials. I think if I recall correctly, I think we just needed to pass in too many parameters that named credentials weren't able to handle. And so it was just easier for us to do that using custom metadata. But I know at least on a couple of the things I've worked on, we've looked into named credentials at some point, and they didn't meet. At the time we looked into them, at least they weren't built out. And then at some point, if you have a kind of working framework built out, as long as you're not hard coding things into your code, it doesn't necessarily make sense to try to move everything to named credentials. But it is definitely something I'd recommend if it'll meet your use case.
Yeah, so
Thanks.
a little bit on name credentials, Nagesh. So I do use some of the scenarios where, so we don't store the OAuth credentials in name credentials. We can set it up and store that, but we explicitly save this into protected custom settings for one of our integrations and on the fly. So you can set up everything in name credential, like the authentication method. You don't need a remote site settings because it's part of that endpoint name credentials and even the authentication. So you don't have to make a call out every time to get a new token. So it itself does that. And you can bypass also if you want to do, you can configure through configuration, or you can bypass and you can use HTTP request and put those token and everything manually in code, and you can overwrite that. So there are multiple ways to do. Yeah, that's pretty cool way to build the API security.
Thanks, Manoj. Thanks, Adam.
I see one other question in chat from Nilesh. Can you explain more about private class testing? I'm assuming you mean like private method testing within a class. I didn't really get into that, but there is an annotation you can add to private methods called test visible that will basically allow you to call your private methods directly from a test class. So if I wanted to unit test this update purchase order method, I can leave it private, but add @test visible on it, and then I can call it directly from a test class without having to make it public. So hopefully, Nilesh, that answered what you were referring to, but
yeah, got it. Great,
okay.
thank you.
So any more questions?
Yeah, any more questions? If not, then feel free to reach us or Adam directly. And again, he has a variety of resources. It's really inspiring and really good stuff. I would recommend definitely check it out. We're learning Salesforce, learning development skills. So that's really cool things. At least give some insights. So I'm going to stop the recording and then we can go for our swag giveaway.